In this video, we'll talk about how to factor difference of squares questions. We'll start off by reviewing simplifying, which in this case is expanding and then simplifying. We apply the distributive property. So first times first is x squared. Outsides, negative 6x. Inside, and then last. We collect like terms and realize we've got a 0x. So essentially that middle term doesn't exist. Now factoring is going the other way. If we start out with an expression such as this, it's much the same as having a simple trinomial that looks like this. And before, we needed to find two numbers that multiplied to give negative 36, and here combined to give a 0. The numbers would be negative 6, positive 6. Difference of squares questions are much like perfect square trinomial questions in that we have to know the perfect squares. The diagonal contains all the perfect squares, and of course that would go on forever. You need to be able to recognize these perfect squares. In addition, we also need to consider fractions. So for example, if we have 1/3 times 1/3, we get 1/9. That is a perfect square. X times x, x squared is a perfect square. X to the 6, y to the 6 is a perfect square. We can write several perfect squares. For example, 4/9 is a perfect square. X squared, y squared. A to the 4, b to the 20 would be a squared over b to the 10. And we could continue making up examples. Important thing to remember is we have two factors that are identical when multiplied together will result in the perfect square. Now there are some hidden perfect squares you need to be able to recognize, and the way you find them is you take out a greatest common factor. First step, always check for a common factor. So can we find any here that have a common factor? Here's one. Here's one. Let's do those first. Take out a common factor of 2, and you're left with x squared minus 25. Take out a common factor of 7, and you're left with 4m to the 8 minus n squared. Now all of these questions have something in common. The first term is a perfect square, and the last term is a perfect square. First question, we have a difference of squares. So that means our signs are going to be different. X in the front, and then square root of 1 gives us 1. We do not have a difference. This one cannot be factored. Here we have a difference. We've taken out that common factor of 2, so we need to leave it there. X and square root of 25. For this one, we can rewrite. We have a difference of squares. X, square root of 16, 4, 4. We have a difference of squares. We write plus minus, and the last would be 1/3. We have a difference of squares, so we have a plus, minus. The first term results in a 4, and the second, the square root of any square number will be that number. So we can just rewrite the inside bracket here. And this can be written as 4 plus x minus y times 4 minus x plus y. And that's fine. And the last one, make sure you keep that common factor outside of the brackets. And we have a plus minus because it's a difference of squares question. 2m to the 4, 2m to the 4, and n. And we'll check a few of these just to make sure we're right. Let's check this one. So what we do is you write the 7 bracket. Now we'll do the FOIL in the inside and get 4m to the 8 plus 2m to the 4n minus 2m to the 4n minus n squared. These two terms cancel out, they become a 0, and we're left with 7 bracket 4m to the 8 minus n squared, which is our exact initial expression when we distribute. Should we check this one? We have a squared over 64 for our first. Outside we can write as minus 1/3 times a over 8. In our inside last we have plus 1/3 a over 8 times in between minus 1/9. The middle terms become 0 and we're left with our original expression. We should talk about 2 more examples. The first one we previously rewrote as x squared minus 16. We could have also done this question by taking out a common factor of -1. Now we have a difference of squares, 4 in the front and x in the back. These two answers are exactly the same. Why is that? We can rearrange the factors in multiplication. So if we have the x plus 4 first, then we can distribute the -1 in. So we essentially have the exact same result. In this example, we have a difference of squares, but now we have another difference of squares. Let's do a final check. We have x squared minus xy plus xy minus y squared. The middle terms cancel. And a final FOIL would be x to the 4th minus x squared y squared plus x squared y squared minus y to the 4th. And we're left with x to the 4th minus y to the 4th.